I would like to express a warm welcome to everybody. It's a pleasure to have that lecture on mechanics and on doing phenomenology in science education. My name is Wilfried Sommer, and my professional work has its focus where high school education and university education meet. On the one hand side, I'm a high school teacher in physics, and on the other hand side, I'm a professor for school education focusing on phenomenological teaching methods. I am working in an institute for subject-related methodology in Kassel, and that institute is closely related to Alanus University for Arts and Social Sciences. And as a professor for school education, I'm working at Alanus University. Our Institute for Subject-Related Methodology in Kassel has a close cooperation with the Teacher Training College in Kassel and the Pedagogical Research Center within the Federation of Steiner Waldorf Schools in Germany. Okay, let's get started. I would like to talk on doing phenomenology in science education. And while doing so, I'm going to relate to a very famous paper from Östergaard, Dahlin, and Hugo that was published in 2008 in Studies on Science Education. And in their research review, they looked at the framework of doing phenomenology in science education. And my main focus today will be doing phenomenology in mechanics, especially in statics. And while relating to mechanics, I'm also relating to the curriculum of Steiner Waldorf Schools, grade 10. There, the students learn mechanics. They learn the transition from a bodily situation to the transcription of that bodily situation with vectors. And so forces are dealt with in a way that you can look at the interaction in a bodily situation on the one hand side, and you can look at closed vector change on the other hand side if you deal with a balanced equilibrium, for example. And the main aim in grade 10 in an educational aspect actually is that the students learn the coincidence about their forming mental pictures and what is actually taking place as an interaction in a bodily situation. There is a frequent misconception about forces. This misconception relates to a concept where forces are to some extent the perpetrators that make the world go round. I do not want to relate to that aspect. I want to relate to bodily situations with a specific interaction, and I would like to introduce forces as a geometrical way to describe the conditions of an equilibrium. You will have been realized that I will relate to statics, and I will relate to doing phenomenology in statics in grade 10 physics education in a Steiner Waldorf school. The method in Steiner Waldorf schools is doing phenomenology in science education. Okay. Now I would like to share my PowerPoint. As an introduction, I sometimes looked with my students at a viaduct. You can meet that viaduct in France. It's over the river Vior. And that viaduct has been built in the 19th century, and it has that kind of construction where the order of the beams reveal how pressure and tension actually occurs in the building itself, especially in the beams themselves. And you can connect to that situation in a bodily sense. You can feel by looking at this upright beam here, like standing here, stretching your arms and forming with your arms half the part of an arc. And in this arc here, that would be your right arm, that would be your left arm. And you can see that the two half arcs here are balanced, like you can balance your arms in an upright position. And you immediately realize that the first upright beam here is under pressure. And if you start replacing yourself at the position of this beam, you can feel through your bodily perception that that very beam here has to be under pressure too. If you take it away and you replace yourself at the position of that beam, it would be your job really to perform a lot of pressure in order that the bridge will not break down. So you have pressure here and correspondingly in the other beams here. And if you relate to a beam here, the beam that actually supports the rails, you use your bodily perception to perceive what's going on here, and you replace yourself at the position of this beam, you can realize immediately that this beam here has to be under tension, because this part of the arc here actually has all its weight that has to be held here by that beam. Okay, so that is a very first approach to statics, that you look at a construction where your bodily perception enables you to get a first understanding of what's going on in that bridge, in that construction. And so your bodily perception tells you something about pressure and tension within the construction itself. That might be an introduction, and then you can proceed and, for example, start with an experiment where you have a swing here, you have a student, and that student here is lifted or pulled upward by another student, and this student here has to have at least the same weight as the student here. To be correct, his or her weight has to be slightly bigger than the weight of the student on the swing. And he or she has to exert a lot of force. It is really strenuous to pull his or her body upwards. If you compare that to a situation where the student has to pull up him or herself using the pulley, the way it is denoted here, you will realize that it is much easier to do so. And the students here will use half of his weight to pull him or her up. And that weight half of his weight he uses to do so, and that is connected to his hands and rope, is used to pull the other part of his bodily weight up. And so you have very different situations, and these different situations are investigated, or you have an approach where the students are embedded into what's going on. And in the next step, you can just go from the embedded observer's perspective to an external perspective, and you can start measuring. And that is a typical approach in doing phenomenology in Steiner-Waldorf education. You start with a particular that contains a universal, and that universal will be revealed step by step. And while doing so, you proceed from an embedded observer's perspective to an external perspective. Now I would like to proceed using my document camera. I will share it. Here we are. To sum it up, doing phenomenology in Steiner-Waldorf education means that you relate to a particular that contains a universal. Then you shape the lesson in a way that you make the implicit explicit. We will discuss that, how to make the implicit explicit. The universal is implicitly contained in the particular, and you frequently start with an embedded observer's perspective, and you proceed to an external perspective. That is the framing in subject-related methodology, and I started in a way that we had an introduction, the VR viaduct, and then you have in the embedded observer's perspective the swing and the students. And now I would like to proceed in a way that I have the ceiling here, I have the pulley here, and I will include here or embed here a spring scale. I have ropes here. I will include spring scales as well. And I will have a weight here. And in the optimum, that weight is given already in newtons. Otherwise, you would have to tell the students that one kilogram approximately correspond to 10 newtons, and we are going to measure forces in Newton, and you have your hand here holding this part of the spring scale. And I would recommend to use a pulley like this, and I would recommend to use a really good and large spring scale like this. And before proceeding with my PowerPoint, I'm sharing my screen once again, and I show you where you can buy that. So now I'm going to share my screen here. And you can see the company here, that's Wenger Lehrmittel in Germany, and they offer these spring scales. And our institution here has, you can see here, Lehrerseminar-forschung.de, has a Lehrmittel shop, has a shop for teaching aids. And if you just go here, you can choose as a language here English. And you can search for pulleys. And you can find everything. Okay. So just that you had know where you can buy it. And now I am proceeding with my PowerPoint. And we started here with the embedded observer's perspective. And now you can investigate with a new experiment here the spring scales. You lift a weight here with your hand, and then you connect the end of the spring scale here with the weight. And while doing so, all the forces here are reduced. While doing the demonstration or the experiments, I'm just relate to the term forces as a matter of course. We will not discuss that at this stage of the lesson. We just use it in a very regular way, like you use it without having started thinking. And then we will proceed with the concept building step by step. I would do on the first day the experiment in the embedded observer's perspective and in the external perspective. We would take notes here in the left part of the blackboard. And then on the following day, we would start with the concept building. And for the concept building, I would use these parts of the blackboard here. That is a part where I can take notes, and then I can cover it with a flip chart. The idea of that experiment is that the students can compare what they experience in the embedded observer's perspective with the external perspective. The external perspective in this part here is very easy, and that helps the students to realize if they just pull themselves up, that one half of their bodily weight will be used on the right rope to pull the other part of the body that is located on the swing on the left part of the rope, to pull that up. Here, the left part is the body you have, and the right part is the body you are. You identify with your body, you exert force, and the force you exert, that is the body you are on the right-hand side, and that holds the body you have, where you just have weight and you do not have the feeling to exert force. So the students can relate to this, and then it's pretty clear if you pull somebody up, that the load of the ceiling is twice the weight you pull up. And you can look at this here. And then the students need help, or you have to give a certain impulse as a teacher. And you have to can ask, what about the interaction in point X? And the interaction in point X can then be described. And by relating to that description, you can just tell the students that you can describe that interaction geometrically by just relating to one point X here. You have to write it, and that you have that the load here and the tension here can be represented by arrows. Those arrows are called vectors, and you scale them, and then you have force diagrams relating to the situation A and B here. That is not very difficult. You can do it in a pragmatic way, and you can tell the students that you can represent it in two ways. You can show that you have an equilibrium here by drawing the vectors this way as a closed vector chain. You can relate to in the free body diagram to it in another way, that you relate directly to X and you draw the forces this way. So the experiments I proposed here are a way to introduce in a very pragmatic way forces as vectors, and you introduce those vectors as a geometrical description for an equilibrium. And the tension or pressure that you actually can feel in an embedded observer's perspective now is transformed into a concept where you represent it as a force, and the strength of or the magnitude of that physical quantity is represented by vectors. Okay. In the progression of this physics main lesson block in grade 10, in the next step, you can start to change the angle between spring 1 and 3. If you choose it for 120 degrees, then all the forces are of the same value, and the students can do it by themselves using the spring scales I showed to you. You can fix the spring scale on the ceiling here. You have the pulley here, and then they have to balance it. You can see the students that they have to be very careful while balancing it. You can measure here the angles, and then you can draw it on the blackboard. And I always draw lines of reference in here to make very clear how the angles actually are. And then you can ask the question on the following day or by building concepts, how do we have to represent the equilibrium here? And the closed vector chain will work. You can just test a hypothesis. Does that work? And it works. And so the students can really experience that there is a coincidence between building mental pictures in a certain way and the equilibrium in a bodily situation. And then you might proceed with another experiment. And I would like to show you that experiment now. And to show it to you, I have to change my position. So you just have to wait about 30 seconds. And I will represent the experiment or the demonstration in a way that I would like it to do in front of the students. So I'm not going to talk a lot. I'm just trying to guide their observation. And I try to do that in front of the camera as well. So I am going to deal you to some extent like students. We will meet in a couple of seconds. Here I am, and now I'm going to start. That's a matter of course, isn't it? I have 10 newtons here, I have 10 newtons there. And here are 10 newtons as well. Oh, these are at least 20 centimeters, aren't it? Okay. So we start here again. And now I'm going to move here. Isn't that wonderful? If you observe that angle, I think that's wonderful. Now I'm going to increase here, 12 Newton. 14. I'm going to move. Okay. Okay. We will meet in a minute again. Okay. That could be a demonstration on a following day. I'm going to share my PowerPoint. This is the experiment I already discussed, and now we are going to this experiment here. And if you start to look at this, you have a diagram of the bodily situation. And now you introduce here lines of reference. And with that lines of reference, you can relate to two ways for a closed vector chain. You find that it works. It will work for an angle here of 90 degrees as well. That is a way that the students can do it by themselves. And so the students know now that they always have to draw a diagram of the bodily situation, that you can describe that geometrically with closed vector change, and that there is a coincidence about both. And you really stress that coincidence by all the experiments. And that is a way that you help the students in their development as adolescents, that their mental picturing and what they actually meet in the world has a correspondence. That is one of the aims of that part of the physics education. And if you have that geometrical description, and if you know trigonometry, then you can calculate it as well. Then you have to do a lot of exercises. That's a matter of course. For example, you have a boat here being drawn by two horses. You can look at the equilibrium here of that point here, and then you can reinterpret that equilibrium here as a net force here being built by the two forces F1 and F2. And so you can just use an exercise to proceed from the closed vector chain here to the net force. And then in the next part, you can also relate to the decomposition of forces on an inclined plane by reinterpreting the closed vector chain here. And I'm going to show you that experiment as well. You have to wait a minute. I am going to change my camera. You have the experiment here, and I'm just going to take away that weight here. Isn't that well balanced? Okay, now I have to be careful. Oh, it's still well balanced, okay. And now, here, it's on the plane, and now it's nearly on the plane. Here we are again. I wanted to show you that you can shape doing phenomenology in mechanics, especially in statics, in a way that the students really learn to relate the bodily situation to the closed vector chain if you look at the interaction of a balanced equilibrium in a certain point. And to sum it up, I'm going to share my document camera. Here, that is our approach here. And if you look at the development or the education that is connected to this approach in physics teaching, then the students are supported in their development that they learn you have a conceptual realm where you build mental pictures, where you formulate mental images, and you have a bodily situation. And that with that bodily situation here and the conceptual realm, there's a coincidence. And that coincidence between your thinking and what is appearing in nature can be practiced in an archetypal way in mechanics. And that is something students meet in their life through physics education. So far, relating to a phenomenological approach in mechanics in grade 10. And I'm looking forward to meeting you in the next lecture relating to grade 11 in Steiner Waldorf schools and to the relating to the correspondence of field and charge in electricity, especially in electrostatics. Meeting you soon. Bye-bye.